Okay. Assalamualaikum. Hi, everyone. Today I'm going to give a lecture regarding chapter 11, yeah, file system implementation. Okay, here in this chapter, we have a couple of subtopics. First, file system structure. Second, allocation method. Next, free space management, recovery, and finally, summary of this chapter. So, objective of this chapter are to describe the details of implementing local file system and directory structures. Second, to describe the implementation of remote file system. Finally, to discuss block allocation and free block algorithm and trade-off. File structure, yeah, file system structure. Overview. Okay, file structure consists of logical storage unit and also collection of related information. File system resides on a secondary storage or disk. So provided user interface to storage, mapping logical to physical. And then provide efficient and convenient access to this by allowing data to be stored and also located, retrieved easily. This provide in-place rewrite and random access. Yeah, I/O or input/output transfers performed in block of sector. Usually, the size is about 512 bytes. Okay. File control block is a storage structure consisting of information about a file. And device driver controls the physical devices. File system organized into layer. Yeah. Okay, this is the one. So this is the figure for figure 11.11 represent the layer file system. Yeah. Okay, start with application, program, logical file system, file organization module, basic file system, I/O or input/output control, finally devices. So logical file system actually manage metadata information, includes all the file system structure except the actual data. File organization module actually understands files, logical address, and also physical blocks. Basic file system is to use generic commands to the appropriate device driver to read or write physical blocks on the disk. I/O control. Okay, I/O control consists of device driver and interrupt handlers to transfer information between main memory and the disk system. Okay. So here, all this you can check in our layer file system. Right? Okay. And for the file organization module, which is for understand the file, logic address, and physical blocks. Okay, this will translate the logical block number to the physical block number, for example. Hashtag mean representing the number or some reference, and then manage this allocation and also free space. All right. So that's the purpose of file organization module in this layer. Okay, overview, allocation methods. Want to see this allocation method, how can be done, So overview. This is a direct access device, does give us flexibility in the implementation of file. The main issue is how to allocate space to this file so that this space is utilized effectively and file can be accessed quickly. An allocation method refers to how these blocks are allocated for the file. Okay. So three major methods of allocating this space, in white, we had contiguous, link, and also index. So three methods. So contiguous means extend basic system. Contiguous is continuous to represent. Link scheme. Okay, index. Okay, index here. There is a index scheme, multi-level index, and combined scheme. Okay, so all this created under index block structure. Okay, so go for the allocation method, which is contiguous allocation. So each file, occupies set of contiguous blocks. This is continuous, the big block. So best performance in the most cases, and simple, only starting location, is required, which is start with the first block number, and the length of block are required. All right, that's contiguous allocation. So problem includes, like finding a space for a file, and then difficult for file extension, and knowing the file size, which is until the maximum, and also during we assigning the what we call this, the program to the specific allocation, when do allocation, so this will create the external fragmentation, especially on the disk space. So after that, when there is an external fragmentation, we need to do this for compaction, because there is an in out process for the they occupy the memory or space, whatever. So we need to compact again. All right, otherwise it will scatter the size of the empty space. So that's the issue, for the contiguous allocation, right? Okay, allocation method, mapping from logical to physical, Okay, this figure 11.5, contiguous allocation of this space, How it get done, So I want to see that. Okay, first directory. Yeah, this is a directory. File start with 0 and the length is 2. Yeah, length is 2. Okay, start with 0 and the length is 2. Okay, and then next, we have a file named tr, for example, and then start at 14 and then length is 3. So 14, length is 3. 1, 2, 3, for example. Yeah, and then mail, we have start at 19 and then length is 6. Okay, we can count 1, 2, 3, 4, 5, and 6 here. Right? Okay. So next for the list, it start at 28 here. How many length? 4. So 1, 2, 3, and finally 4. Okay. And for the F also, start at 6 and length is 2. Yeah. Start at 6. Yeah. Length is 2. So 1, 2. Okay. All right. So that's contingent allocation. Yeah. Techniques or methods. All right, on this space. Okay, contingent file storage for a file A and B. Okay, here you can see free space. This is the file A record 1, file A record 2, file A record 3, record 4, 5, and here you can see file B. Okay, record 1, record 2, record 3, and also record 4 for file B. And next, there is a free space here. And in this diagram also shows that file C record 1 at the end of this diagram. Yeah. Okay. So this is a slot. Start from free space here, 0 until 11. So we got this slot. So there is a number 0, 0 till 12. Yeah. And then file A, this file cannot be expanded for a new record. Solution, rewrite into a larger storage area. Okay, for example, file A, this file cannot be expanded for a new record. So solution is rewrite into a larger storage area. Okay, so this is a problem of contingents. Okay, so we need the size bigger than the existing, like this. Okay, so file, okay, the size must be bigger than this file A, for example. Yeah, so in order to bring to the another area. So means solution is rewrite into a larger storage area. So means the size must bigger than the file of this. Yeah. So file B, this file can be expanded, yeah, by only one record, that replacing the free space at slot 10. Okay, here. So this file can be expanded by only one. Okay, at slot 10, yeah. Can be expanded by only one record, that replacing the free space at slot 10. Okay, so you can add one more here, slot 3, next to this file B, but not in for file A. Yeah, not for file A. Okay, extend base system. A file will grow slowly over a period of over a long period, month of years, for example, and also it must be allocated enough space for its final size, even though much of the spaces will be unused for a long time. So this will create internal fragmentation. Okay, all right. The solution for that is a modify contiguous allocation scheme. So a contiguous block space is allocated initially. If not enough, another contiguous block known as extended is added. And next, solution, a file may consist of one or more extend blocks. Yeah. So this is the modification from the original contiguous allocation scheme. Okay, so they call this method as modified contiguous allocation scheme. All right. So link allocation. So each file is a link list of blocks. Okay, when they implement this, so no fragmentation, no external fragmentation will occur. Yeah. So each block contains pointer to next block. So free space management system call when new block needed. Okay, this is for link allocation. So this example 11.6 is this will represent link allocation of this space. Yeah. So example 3, yeah, a file of a 5 blocks start at block 9. Okay. All right. Start at block 9 and continue at block 16. Okay. Based on the pointer. Start at block 9 and then next at block 16. And then block 1. Then block 10. And finally block 25. Okay. So 16 first. And then goes to block 1, then block 10. Next is block 25. Yeah, 25. Yeah, like that. Each block contains a pointer to the next block. So each pointer actually, yeah, there is a next block. And finally, it points to the minus. Means it's a final. Yeah, all right. Okay, this is link allocation of this space. Okay, allocation method. Example 4. So a link allocation with a file is start at block 2 and continue at block 8, 20, and 18. Okay, block 2 started and then finally at block N, and file B also start at 3 and then it will end at 11. Yeah, 11 blocks. So so each block, okay, includes its address and a pointer to the next block of the file as well as the list. Okay, file A, it has a number of extent is 3. Yeah, and then number of extent for file B is 2. Okay. So file A, okay, start with that. This is from this directory entry table you can see here, all right? And then file A, start with file A, start at 2, and next is 8. Okay. So point to the 8, and from that next shows to 20. It's point to the 20, and next it point to 18, and next final. The minus means the end of the content or block address. Yeah. Next B. So B start at 3. So 3 here, right? Here start at 3. And next 6 goes to this 6. And next goes to 11. And then after 11, end of the content. Yeah, all right. So example 3 and 4 are sequential access file. To find a I block of a file, it start at the beginning of that file and follow the pointer until the final block. Yeah. Disadvantages of this method. Locating a block can take many I/O or input output and these 6. Yeah. And reliability can be a problem. What if one of the pointers get corrupted? So this is the couple of disadvantages of this method. Solution for this, they call a file allocation table or FAT. Yeah. So the solution are beginning of volume has a table and also indexed by block number. Next, much like a linked list, but faster on this and catchable. Yeah. And then new block allocation. New block allocation simple. Right. So this file location propose a solution for the above problem. Okay. On this disadvantage. Okay, allocation methods. Yeah. So first, can see we have a fat structure for a file test. Yeah, test here, and consisting of this block. Okay, so this block starting at 217. Okay, start block 217, and next 168. Okay, next is 168, and finally is 339. Finally is 339 here. All right. So allocation, yeah, method. So this is directory entry. And this is example 6A, which MS-DOS, which use a link allocation FAT, yeah, FAT, file allocation table, okay, using this scheme. All right. So file A, so address 2, okay, address 2, file A, okay, so address is 2, okay, and then next is the H. So where is the 8? H is here, which is the address of the 8. Okay, check is the address of 8 here. And next, so here we'll point to the 8 and the file A. And after that, '20. The next is 20. Where is 20 here? So we'll point here. Okay. Next, here, file A, address is 20, and the next is 18. Okay. So 18, so it will be point to here. Okay. So next 18, here, file 18, the address. The graph is here in the diagram, it's here, and then next, we represent the 4, point to the 4, yeah, 4 blocks. Okay, all right. And then see again for the file B, address 3, and then next is 6 goes to the address 6, Okay, address 6. And then next, point to the 11 next. Okay, 11 here. So file B is 11. So here is 11. It goes to 11 next. Then next goes to 3. And then this is the end of file here. No more file B. Okay, so they will finish. All right, they will finish. Okay, and next I want to see on index allocation. So each file has its own index block, okay, or pointer to its data block. Okay, we got this logical view representing that index table. So each of this will represent to the points to the data block. So needs in that table, of course, yeah, and then there are random access, and next dynamic access without external fragmentation, but have overhead of index block. Yeah. Example 7. Yeah. The directory contains of the address of the index blocks, and then to find and read the I block. Yeah. The pointer in the I in that block entry is used. Okay, in order to find that. Okay, so figure 11.8 represent example of index allocation. Assume that each block can only store 8 block addresses. Yeah. So we have this 8, okay, altogether 8 block addresses. Beginning, yeah. This, okay. We have 8 block addresses. So start with 9. Next is 16. Next, after that is 1. After 1, it goes to 10 based on this, yeah, blocks. Next is 25. And next, finally, is minor. Minor is the end of the final. Yeah, the final. So no more data. So that represent. Okay, if you do calculation, normally you can, if you remember that until -1 mean end of file. Start with 0. Sometimes in looping, want to check the whole data in the loop. So until -1, that's a normal practice. Okay, -1 is until the whole list or all the loop, all the content of the array, for example. Okay, so it means by here also we put -1 to represent no more data. Okay, all right. Allocation method, example 8, index allocation for 4 bytes each block. Yeah, all right. So we got this file number 1, index block 12. Okay, so 12. So it say that 4 bytes each block, 4 bytes each block. 1, 2, 3, 4. So 4 blocks. Okay, 2, 8, 20, and also 18. Okay, 4 bytes. So means one represent one entry represent 1 byte, 1 byte, 1 byte, 1 byte. 4 byte altogether. Yeah. Okay. Next, start at 2. So point to the 2. And next, point to the 8. And next, it will point to the 20. And finally, 18. Okay, there's a, okay, in the allocation for 4 bytes for each block. All right. Then file 2, index block is 4. Okay, index block is 4. Okay, yes, 3 and 3, got 3, 6, 11, and minus. Minus 1 is the final one. Okay, so I mean, it's not the data, actually, the final. Okay, 3, next 6, 11, that's it. Okay, so minus 1 is not represented, but represent the end of blocks. Okay, all right. Okay, so index block size dilemma. If the index block is small, so what happens? It will not be able to hold enough pointers for large file. So that's the issue. Yeah. And next, if a large file is even large, if the index block is a large, what happens? There are maybe lot of unused space if the file size is small. So this is the issue, yeah, for the index blocks. Okay, minus 1 mean end of. It's not it's not a data actually, yeah. So representing no more data, all right? Okay. The solution use the index block structure. So in order to resolve this, okay, to sort it out this problem, yeah. Here they call index block size dilemma. So they put a solution as using, yeah, index block structure. Yeah, index block structure. Okay, index block structure consists, okay, linked scheme, multi-level index, and combined scheme. Yeah. And then for the index allocation, link scheme. Yeah. Example 9, we have a blocks, which is this is number of block here. Okay, starting by 9, anyway 16. So assume each block can only store 5 block addresses. So one block can represent or stores 5 block addresses. Yeah. Okay. 9. Okay, index block 9. So next block 9. So it will consist of 5 blocks start by 12 here. 5, 3, 4, 7. That's a final. So here until 7. Yeah. And next, so we got the another, yeah, block 7, and it will consist on 2, yeah, 2 addresses, 1916, yeah, block addresses, and the rest is empty, right? Okay. Similar to this, we got example 10 here, 2 index level using the same method. This one for multi-level index. Yeah. And also for this kind of thing, directory, so representing the same issue. Yeah, for multi-level index. Right. So for index allocation, a combined scheme. Example 12, the Unix sysfile system or UFS. Okay, 4K bytes per block. 4K byte mean it will represent 32-bit addresses altogether. Yeah, with 4K bytes per block. Okay, this is the diagram, which is the combine, yeah, how they combine each of these. We got mod, honor, timestamp, size block. So this is the allocation scheme here. Block, got the data and so on. Okay, this is the combine all together inside. Yeah. Okay. And performance. The best method depends on file access type. Continuous great for sequential and also random. Links are good for sequential, not for random. Okay, so finally they found, okay, because normally when we creating any algorithm which is related to this kind of the problem, so we will talk about performance, how we can achieve a good performance. Okay, finally they found this. Okay, this is the result actually. Yeah. And then next, declare access type at creation. Select either contiguous or link. Index is a more complex. Okay. So it implements single block access could require 2 index block. Yeah. 2 index blocks, reads, then data block, read later. Okay. All right. So free space management. Okay, after we want to swap everything. So free space management is very important. Overview. Since this space is limited, we need to reuse the space from deleted file for new file, if possible. Okay, file system maintains a free space list to track available block or cluster. Okay, so we use the term block for simplicity. Okay, all right. So there are 4 techniques: bitmap vector, pre-linked list, grouping, and next is counting. Yeah. All right. So bitmap or bit vector for n blocks. The list of these bits. 0 means free. Sorry, 1 means free. 0 means block is used. Yeah. So the calculation of the first 3 block number. The first non-word is scanned from the first bit, which is the location of the first 3 block, which is the location of the first pre block. Yeah. Okay, how? Okay, assume example 13. Yeah. Assume there are 8 bits per word. 8 bits per word. So one word got 8 bits. And bit map is as follow. Okay. All right. So the condition is 8 bits per word. So this one word. Okay. So how many bits? 8 bits. One word, 8 bits. And then starting from they will count here bitmap 000 until free 1. So we start from here. So this is the first free block. So offset is 4. Yeah. All right. To find the address of the first free block, so the number of the bits per word. Okay. Of course 8, and the number of 0 value word. Number of 0 value word. Yeah. Okay, 1. Okay, 0 value, what 0 value all together, and then they found 1 here. Yeah, and plus offset for the first bit is 4. Okay. All right. Number of 0 value word. Number of bit 8. Number of 0 of a 0 value word 0 until here 1. Okay, that's mean by that. Yeah, and then plus 4 and calculate, we got 12. Okay, 12 is here. Okay, there's a block number. Start the block number or block address. Yeah, that's one. Okay, all right. So 11.1. Given a bitmap value 0 means use, 1 is a free. Okay, 1 free. Okay, look for this slide. Yeah. Okay. Case 1. Block size is 1K. Okay, they start at, and then next 1K, and then start at block number 8 for another 1K, and address 10, and 1K and 12. So this is 2, 3, 8, 10, and 12. Okay, so this is the address for each of the 1K block for the first case. Next, okay, next we got case 2, 2K. So we start at 238, yeah, 238, 238, for example. And next, for another case, which is case 3, okay, 2 and 3, okay. So because this is the 1, okay, 0 is a use, but 1 is empty. So we have to give attention on this block, yeah, start block. Okay, all right, yeah. And next 2 and 3 for 3K, so 2 and 3 here. And next for 5K, number 4, side 2. And next we got another addresses 238, yeah, 2, 3, and then 8 here because of this. Yeah, another 10. Then this one and this one. Okay, and also the rest of that, another 4 addresses. Okay, so this is how, okay, they do this mapping, yeah. Okay, so free space management on regarding free list. Okay, linked list or free list cannot get contiguous space easily. So no waste of space, no need to traverse the entire list. If block is free, block are recorded. Okay, so figure 1110 link free space, yeah, on a link a free space list on a list, yeah. Okay, so grouping. So modified linked list to store address of the next, yeah, of the next free block in the first free block, yeah, plus a pointer to the next block that contains free block pointers. Okay, like this. So free block list, we have 2, 3, 4, 5, 8 till 12. Assume that each block can only store 3 block addresses. Yeah. So block 2 and 3 block addresses. Next, another addresses, and next 10 and other addresses or entry. Okay. So not block 2, 5, and 10 become index block and cannot be used for data block. Yeah. All right. So counting, because space is frequently contiguously used. Yeah. And free. Yeah. With contiguous allocation algorithm, extend or clustering. So keep address of the first free block and count of following free blocks. Okay, and then free space list, then the free space list then has entries containing addresses and count. Yeah. Consistent checking. Compare data in for recovery. So consistent checking, compare data in directory structure with data blocks on the disk and try to fix inconsistencies. Yeah. So it can be slow and sometimes fail, right? And next, use system program to backup data from this to another storage device, such as magnetic tape, another magnetic disk, and optical. Recover lost file or disk by restoring data from backup. backup. Yeah. So for the summary, the file system reside permanently or secondary storage in a disk. Yeah. So provide this physical disk may be segmented into partition to control media use and allow multiple file system. Right, for the partitioning on the disk. Any file system type can have a different structure and algorithm. The various file can be allocated space on the disk in three ways. Yeah, contiguous, links, and also index allocation. Yeah. And free space allocation method also influence the efficiency of this space use, including performance of the file system and also reliability of secondary storage. Yeah. Using this bitmap, linked list, grouping, and also counting. Right. Okay, this is the exercise that you will find in the books. Okay, so this represent to this topic. You can try this one later. Yeah. And this is the end of chapter 11. Thank you for listening and watching. See you in the next slide. Yeah. Okay. Assalamualaikum. Bye bye.